Okay, I think that's everyone. Welcome back. Hopefully we all got a chance to play around with this code a bit and moving the position of these squares. We're just gonna quickly go over the solution here so we have it. So here's the code you should have started with. Shrink it. We have the two squares defined with rect here. And from the first square to the second square, we're changing the x position by 400 to move it to the other side of the screen. So the question is, how much do we need to change it if we just want it to be to the corner of the square? Well, since the width is 100, we need to change the x by 102. And then the y, since we're moving it up from the original square's position, that would mean it needs to be minus 100. Because reminder of the coordinate system, 0, 0 starts at the top left. So the further down you go, that's going to be a bigger y value. So if you want to move up, we need to subtract from y. Okay, so let's try running that. So that's how we can get a second square, just kitty corner to the first square. And if we wanted to have the pattern with the 5 squares that we saw in the slides, you can just copy that same code 5 times. Like that. Now you may notice this is the same code copied a lot of times. If only there was some kind of loop we could use so that we don't have to write the same code a bunch of times. Foreshadowing for future sessions. But anyway, we're just going to get back into talking about variable scope. All right, back into the slides here. All right, here's our slides on variable scope. So if you have a variable that's created inside of a function, for example, inside of setup or inside of draw, that variable does not exist outside of the function, and you can only use it within the function it was defined in. In contrast to this, you can have global variables. So if you define a function, or if you define a variable outside of a function, then you can use the global keyword to access that variable within any function, and it will be the same variable. Okay, here's a goofy little analogy to help. So we have global laws, for example, that apply everywhere in the world. For example, like no slavery, that applies pretty much everywhere. Um, but within like certain nations, we may have different laws that only apply within those ones. So for example, in Canada, you must be 18 to drink, but in USA, you must be 21 to drink. So those only apply within those specific functions. So here's an example with in code. If we create the variable x inside of setup here, so here we define x equal to 10, this will only exist inside setup. So if we have defined x here, and then we try to use x within draw, draw isn't going to know what x is because we did not define x within that function. We only know what x is within setup. So how can we get around this? We can get around this by defining a global variable. So how we do this is if we define x outside of both of these functions, then we have this variable that exists and can be used anywhere. But in order to use it inside of functions, we need to use the global keyword. So if we state global x, this will mean that anytime we refer to x in this function, it's referring to this x that was defined up here. Same thing in draw, we define global x, and that means we're referring to this x up here. If we didn't use this and we just defined another variable x within this function, that x would only exist in that specific function. So we need to use global x to use the global variable. So here's another example. You have a question? Can you explain the previous slide? I was pretty confused. Yes. The global keyword or this one? This one, okay. So if we were to run this code, first thing that happens is setup gets run once. So we define size, background, then we define a variable x as equal to 10. And then if we print x, then we can use x however we want. We can print x, that will print 10. We can increment it by 5. So now x will be equal to 15, or 10 plus 5, and we can print it again. So all of these are using this variable x that was only defined in setup. But then after setup, if we try to run draw, it's not going to know what x is because we only defined x for setup. Does that make sense? Okay. So yes, that's a problem. If we do this, the program's not going to run. We're going to come up with an error. How we solve this? We define a global variable. So we can define a variable outside of the function, state that we're using it inside of the function, and then use it however you want. Okay, here's another global example. So if we create x as a global variable up here, and we want to use it in draw, global x will give us access to x inside of this variable, and then we can increment it each time and use it as a normal variable. So something to watch out for draw is any variables that you define inside of draw are going to be written over each time draw is run. Because remember, this keeps running like on repeat as long as your program is running. So if you were to define x within here as like 10 or something, then each time you run draw, it's just going to define it as 10 and then do whatever with it again. But if you use global, then it's not going to rewrite the variable. So it's going to be 10 here, and then first time you run through it, you add 1 to it, it's going to be 11, and then you run it again, it's still 11, you can add 1 to it again, it's going to be 12, and so on. Okay. So with that, hopefully I didn't give away this question too much, but does the following code work as expected to make the circle move to the right? Why or why not? So take a look at this code and answer the question, does it work? And if it doesn't, why not? Oh, did I? Sorry about that. Let me just bring up Top Hat. Here we go. Actually, I'm just gonna share the whole screen so then you can see the code that is referred to. Okay. So yeah, this is the code in question. And just need to figure out, does it work as expected? Okay, only a couple seconds left. All right, just move back to full screen here. And let's take a look at these responses. Okay, so we've got a couple of each responses. So those of you who answered D, that is the correct answer. So if we go back over to the code sample, as I mentioned previously, draw is going to get run multiple times. And that means each time we run draw, it's going to create X again. So first time through draw, X is going to be set as equal to 10, and then we increment it by 1 to make it equal to 11, and then we draw the circle with X at 11, and then the next time through, X is equal to 10 again, and then it gets incremented by 1 for it to equal 11, and then we draw the ellipse with X equal to 11 again. So you see the problem here, it's never going to actually change the value of X because we keep redefining it within this function each time. Okay. So moving on, we can use variables to change other variables. So two variables that we may want to store in another video game example would be, say we want to have the player's X position as a variable and the player's speed as a variable. And then we can update the position variable with the speed variable so that the player will move across the screen at a certain speed. So here's an example of what that would look like with a little ball moving across the screen. So first, we want to create our variable for speed. It lets us very easily modify our program and how fast our character is moving across the screen. So in the first example here, speed is equal to 3, and then we continually update X with the variable speed, and that is going to, each time draw is run, increment X by 3. And so that is going to make it appear to move at a certain rate. But if we want to have it move faster, then we can up the speed to say 5, and then it's going to look something like this, where each time we go through the program, it's going to move at a different rate. Okay, and now we're sort of getting into physics territory. Just answering a question. Do you have to assign X as equal to speed, or could you put speed into the code instead of X? Okay, back to the previous slide. So what we're doing here, so here we assume that X was defined prior to this at like 0, like at the start of the screen. And then each time we're calling this function again, it's getting updated. So first time through, if speed is equal to 3, then X is going to be equal to 3, and it's going to move slightly. Then we go through again, we add 3 again, X is equal to 6, then X is equal to 9, then X is equal to 12, and so on like that, and it'll keep moving across the screen in that way. Did that answer the question? Okay. Yeah, so as I said before, this is kind of getting into a little bonus here with a bit of physics in here. So in real life, the longer a ball falls, the faster it falls. This is because of gravitational acceleration. And so we can replicate this by increasing the speed over time by some acceleration factor. So here's what that would look like. So not only are we updating the position with the speed, we are now also updating the speed with the acceleration, which in this case is just 1, but that can be something different. If you wanted to replicate the Earth's actual gravity, you could set speed as 9.81. Um, but in this case, it falls with acceleration. So that means it's speeding up as it goes down. Okay, so now that's all that we've learned. We're moving into the second exercise. So here, we're going to write a program to draw a circle which moves diagonally down to the bottom right until it goes out the window and disappears. So you want to start with your ball at the top left at 0, 0, and then you want to have it increment so that it moves to the bottom right corner. And then it would continue moving past that, but you can't see it because it's out of the window. Also, bonus to do if you can do this easily, make the circle change gradually from red to blue, as you can see here. Okay, so we're going to go into breakout rooms again and have a bit of time to work on that exercise. Okay, let's see. Got everyone back yet? Still waiting on a few people, it seems. Okay. So now that everyone's back, we're gonna briefly go over the solution to this exercise. So we should have a couple global variables defined at the top here, so then we can change those throughout our function. And so the ones we definitely need to have are our x position, y position, and if you did the color changing, we would need ones for red and blue as well. And so then within draw, we define all of those global variables, so then we can use them within the function. We always want to have our background defined in draw as well. And that is so that each time we're calling draw, we're drawing the background again and then drawing the ball over top of that. So then we're not having just a bunch of circles in a line. We can actually have it so that it appears the circle is moving. So each time we call draw, we increase y by 1, increase x by 1. And then to change the color, we remove 1 from red and then add 1 to blue. So then as it goes across the screen, it'll slowly go from the top left to bottom right, and the color will slowly go from red to blue. And here's what that should hopefully look like. Maybe a bit different, but that is a solution. Okay. So we're just going to finish up the slideshow here with some bonus features of processing. So a few we haven't talked about yet are text and lines. So within processing, we can write text. So we can define the size of the text, alignment of the text within a text box. So here, if we want it aligned to the left side of that box, we can have it aligned like that. And we define our text with this function, which takes in a string, again, within double quotes, as always, as well as the x and y position. We have another function here that'll let us draw lines with processing. So with a line, you define 2 points, and then the line will be connected between those 2 points. So here, this definition of line will have x and y coordinate of the first point, x and y coordinate of the second point, and then the line will just be drawn between those 2 points. And we can add different stroke colors to lines as well, same way we would with rectangles and ellipses. We can also combine text with variables, same way we would with shapes, ellipses, and rectangles. So if we wanted to make the text move diagonally across the screen and increase the size, we can have a font size variable, and we can have our x and y variables. Again, these would all need to be defined as global variables. So this would be defined outside of draw, and then using the global function to state that we're using those variables. And then we can increase our x and y to make it move diagonally like we did with the circle, and also increase the size. Okay. So here's another thing about fading colors. So if we want to make a shape fade from one color to another, we can do that by updating the variables we're using in our fill function here. So again, we did this with red and blue in the previous exercise. But here's an example where we use green. And if we start with green equal to 0, and then slowly increase the value of green, the color will slowly fade to green over time. Okay, so that's all the actual content we have in the slides for today. This is just a reminder for submissions. I believe we had someone bring up that the links on the website for submissions don't work, but these ones definitely do. So if you're in Bugbusters, you can click here to get to the submission form. And perfect, there we go. Submit all of the relevant information, submit the link to your exercises. Perfectly good.
Jeremy,
Um,
sorry to interrupt you. The links on the website actually will work now. So if you still want to update submit to the website, you can still do that now.
that's good to hear. I wasn't sure if those were updated yet. So
Yeah,
you can use those
I was
links
just looking
or
right
you
now
can use
and
these
they work.
links. They both work now. All right, thank you for letting me know. Um, all right, so then the rest of this session will be for working on end of session exercises. So here are some exercises for bug busters using the concepts we learned today. Um, this is another one with moving ellipses and changing colors. So should look something like this, where with the color fading from black to blue and then black to red. And here's another one where we're increasing the size of the circle and having the color of the circle and the background change. So again, using the exact colors isn't important in these exercises. What is making sure you get the concept of having the size of the circle change and having the background colors change. Okay, we have some exercises with Pythonic Lava. We have one here with a pointer that will follow your mouse. Um, and here's another one um, that kind of ties into the gravity concept we were working on earlier. So kind of having a falling ball off a ledge, and you can work on having that speed increase as it falls down. And as always, we have some just for fun exercises. I'm not going to go too deeply into these because they are just for fun. All right, so with that, we will all go into breakout rooms.